I think I called it trig graph. I sent it to y'all. The A in front tells you, if it's skinny, if it's vertical, if it's squatty or wider, if it's reflected around the x-axis, mean negative. The period is 360 over the absolute value of k. So whatever that number is, divided into 360. There's your horizontal shift. And again, positive is opposite. It moves left, negative, right. And this is your vertical translation, which is your vertical shift. So again, I kind of reviewed it. I don't know if I reviewed it with y'all or not, but the parent graphs followed this same thing. And I'm not going to ask you to get too in depth with this because you can do it with technology. So, trying to think of one I could ask you, but we saw some last time. So on let me just do this right quick with you. On 9.6, I think it's 9.6 and 9.7. I'm going to ask you to graph and identify sine, cosine, and tangent graphs. That means TI 84 or whatever you have. Okay. And I might ask you, I'll give you a question. F of x is equal to 1/2 cosine of 3x minus 4 plus 6. And I'll ask you to identify all of those things that are on that sheet. So here's the amplitude. So that means it's going to be wide. This right here, that means 360 divided by 3 is 120. So 120 is our amplitude. I meant not our amplitude. I done forgot it. Period. Okay. And then, of course, your horizontal shift is 4 to the right and vertical shift is 6 up. So that's going to be the extent of 9.6 and 9.7. So this is horizontal shift or phase shift, and this is vertical shift. All right, so I don't want you to spend too much time. Go ahead and send questions, but like I said, and most of the time they'll ask you to graph it after, and then you can graph it on the graphing calculator and compare it to cosine. So I'll do that with you right quick. Let's do this one. And let's go with y is equal to cosine. That'll be the black cosine of x. Close parentheses. And then the blue will be 1/2. So parentheses 1 divided by 2. Close parentheses. Cosine of 3 and 3, cosine of 3x minus 12, 3x minus 12, and then plus 6. And then graph, and you'll see you'll have a vertical shift of, and the vertical shift is 6 up, and the 1/2 is more wide, and the period is 120 degrees. So, and they'll say, what is the graph of cosine and 1/2 cosine blah 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 look like? And there it is right there. Okay, and again, you're probably talking about 3 questions on the test. So I want to get out of this and I want to get to the identities because that is unit 2. The identities is unit 2. So let me get to the identities, and that's going to be 9 point, I don't even know what section it is. Somebody tell me where the identity is. Is that chapter 10 or is it 9.8 or what? I'll look on your, let me look on your outline because I know none of y'all printed it out. So
it's 10.1.
Oh, you're the one. So you printed it out. Okay. Yeah, we're going to start with 10.1, 10.2, and 10.3. Yeah. So that's where 80% of your test is going to come from. So I'm getting there right now and getting to the slides because I'm going to go over the slides because they're better to go over than me writing all over the place. And 10.1. And let me go ahead and do 10.2 also. I got it out. Now I can go ahead and tell you this. 10.1 through 10.3, and I'm just going to go ahead and forewarn you. 10.1 through 10.3 is going to be basically verify / check / prove identities. Yeah, that's basically what it is. And each level, you go up another set of difficulty. They add on a few more identities. Right now, you've learned the reciprocal identities. You've learned the Pythagorean identities. And the, can't think of it, but tangent is equal to sine over cosine, and cosine is equal to cotangent over, I can't remember right now, but anyway, the tangent is equal to sine over the cosine, and the cotangent is equal to cosine over the sine. I think that's it. All right?
Reciprocal identities?
The what?
Is it the reciprocal identities?
No, I got that. Reciprocal identities is the sine is equal to 1 over the cosecant, the cosine is equal to 1 over the secant, the tangent is equal to 1 over the cotangent. So, and that's the green sheet that I sent y'all, which y'all should have that also. But just in case, I'll pull that up too. So you'll have it, or I'll have it when we're doing these problems. I can't remember what I called it. What did I call it? Trig identity cheat sheet.
Is the one you're missing quotient identities?
Yeah, it's right here. I'm bringing it to you right now, and as soon as it pulls up, it's green. It's a green sheet that I sent y'all right here.
Yes.
This is in your files. Of course, I guarantee you only 3 or 4 of y'all printed it out. But here are the two, they're tangent identities. Tangent identity, the reciprocal identity, Pythagorean identities, those are the ones that you know right now. And you might want to add these on, even odd identities, you can add that on too. It's just a negative. These 4 are negative, the rest of them are just positive. So, but that's not really a big deal. These are your big 3 right now. And out of those 3, this is your most important. This is probably your second most important, and this will be the third. Because these right here, you can't do anything without them. All right, so with that being said, let's go ahead and look at the 10.1. I don't use the slides very much. I usually end up taking off of them and going to my whiteboard. And there is the reciprocal identities and the quotient identities. There they are right there. So if you want to make your own cheat sheet, there they are. I'm not going to make it. I'm not going to do that because I got it right here. So I'm just going to leave that on the board for a few seconds. And if you want to write them down again, you can. Cotangent is 1 over the tangent. Secant is 1 over the cosine. Cosecant is 1 over the sine. Now, why do they have those three? Because the secant is written in terms of 1 over the cosine, and the cosecant is written to 1 over the sine. Rule of calculus identities. And y'all already know this rule. What did I tell y'all the rule with identities is? You always want to write everything in terms of what?
Sine and cosine?
Sine and cosine, exactly. So that's why they have these identities right here. They have them in sine and cosine right here, cosine and sine. Now you could write all 6 reciprocal identities, but they want you to know these 2 because they're in terms of sine and cosine. And of course, these 2 are your most important because they are in terms of sine and cosine, and they help you prove other identities. With these 2 work together to help prove other identities. So, you know, you could start off, the easy way to start off is sine, cosine, tangent, cotangent, secant, cosecant. And you could say sine is equal to 1 over the cosecant, cosine is equal to 1 over the secant, tangent is 1 over the cotangent, cotangent is 1 over the tangent, 1 over the sine, sorry, cosine, and 1 over the sine. Now that's if you just wanted to write all 4 of them down. There's no memorizing, you just know because you know the sine, cosine, tangent, cotangent, secant, cosecant, and you know the reciprocals of each other. So just letting you know. Question. All right, complaint. All right, so let's look at the slides. And another thing I found out, the slower I go here, the better. Because if y'all screw up any unit, it's this unit. This is the unit y'all screw up. So there's a Pythagorean identities. That's what I told you was the 3rd most important. And the even and odd identities. I can tell you right now, you don't use these very much, but they might throw a homework problem in on you that has a negative in the wrong place, and you just write it like this. Okay, so you might want to write those down, or you know, put in the cheat sheet, put very seldom used. They are very seldom used. And make sure you can solve for these. You know, solve for the sine, solve for the cosine, solve for the tangent, solve for the cotangent. Make sure you can do that. See right here, express cosine in terms of tangent. Okay, so express cosine, express cosine of x in terms of tangent.
You have a work email.
So that means we got cosine x on the left, and we want it to look like tan of x. I'm sorry, I don't know why I'm yawning so much. As you get to this class, I start yawning. Now, you've already started with the cosine. So the cosine is equal to 1 over the secant. I'm just writing down some things over here. 1 over the secant. There is a relationship between secant and tangent, but that's not going to help you. The cosine is also equal to you can solve one of the Pythagoreans. And let's go to the Pythagorean right quick. Where did my identity go? I'm trying to find I done lost it. The identity page. Where did it go? Hold on a second. It's not there. Not there. Not
Check
there.
under your teams tab.
Yeah. There it is. Thank you. Couldn't remember where I pulled it up. And can I blow this up any for y'all? Layout. I don't think I can blow it up any. I think that's it. Yep. All right, so look at the Pythagorean. You know the tangent is equal to sine over the cosine. That's not going to help us. We got cosine right here. Cosine squared is equal to 1 minus the sine squared, and then take the square root. So that's going to be cosine is equal to the square root of 1 minus the sine squared. So you got several options that you could go to. Cosine in terms of tangent. Where did I go? Where did it go? Okay, there it is. And remember I said the secant, there is a relationship between the secant and the tangent. You could easily use secant here. And that's what I was saying. Cosine is equal to 1 over the secant. And then you could do 1 over the secant. And secant is equal to 1 plus tangent squared, or secant squared is equal. So that would be the square root of 1 plus tangent. And that's where they get that from. See? Cosine is equal to 1 over the secant. So there's 1 over the secant right there. And then you rationalize the denominator. So I can rewrite cosine as x equal to 1 over the secant of x. And cosine is equal to 1 over the secant. And that's equal to 1 over the square root of tangent squared minus secant squared. Because remember, you have to be able, 1 plus tangent squared, you have to be able to solve for the secant. And secant squared is equal to 1 plus tangent squared. So secant would be the square root of 1 plus tangent squared. And then you multiply both sides, conjugate the denominator, and you're going to get positive or negative square root of 1 plus the tangent squared over 1 plus tangent squared. Is that a test question? Yes. I don't like that one. I like the ones that you actually change into sine and cosine. But that could be a test question. All right, let's see if we can find another one that's more. Okay, here's one. Tangent theta plus cotangent theta. They want you to do sine of cosine. Now this is a test question. You bet your bottom dollar this is going to be on your test. Tan of theta plus cotan of theta. Well, I told you a while ago that the tangent was equal to the what? Sine over the what?
Okay.
Are y'all talking or are y'all mumbling? Sine over the what?
Cosine.
Sine over
Sine
cosine.
over.
Sine over the cosine, right here. And the cotangent is equal to cosine over sine. So you're going to use both of those. So sine over cosine, cosine over sine. Sine over cosine plus cosine over sine. Well, we got to get a common denominator. And the common denominator is cosine sine or sine cosine. So cosine sine. Cosine will go into cosine, sine times sine is sine what? Sine squared theta, Hubert. And sine will go into this down here, cosine times cosine is, and what's sine squared plus cosine squared? Go back to your identity. Should be 1. Sine squared plus cosine squared is equal to 1. So therefore, 1 over sine cosine. That right there is a test question. Any question that takes tangent and cotangent and you got to turn something into sine or cosine, that's going to be a test question. Why? Because that's what you're going to see in Calc 1 and Calc 2. And this right here usually screws people up right there
Yeah.
because I got a common denominator. What's the common denominator of 3 and 7?
21.
What did you do?
I multiplied them together.
You just multiply them together. What's the sign of sine and cosine? Sine and cosine. Same concept. So I'm going to go over here to the side. 1 over 3 plus 1 over 7. And this is going to be 3 times 7. 3 times 7. 3 will go into 3 7 times. 7 times 7. 7 times 1 is 7. 7 will go into 7 times 3. 3 times. 3 times 1 is 3. And my answer is 10 over 3 times 7 or 21. Got to have a common denominator. So that's the test question. Let's see what the next one they have for us. There you go. Verify that the following equation is an identity. Cotangent x plus 1 equals cosecant x times cosine x plus the sine x. First thing you're going to do is you're going to go through and see what you can change to cosine and sine. I would focus on that cosecant right there because I would focus on changing this. They want to see if you can change this into this. So take a second and work on it. If you can't do it, then we'll just make fun of you. Let's see, that cosecant. I believe cosecant is 1 over sine, isn't it?
Yeah.
Yes.
Distribute. That's going to be cosine of x over sine of x. And that's going to be sine of x over what? Sine of x. Cosine over sine is what? Cotangent. That's all you got to be able to do. And if you stick with the changing everything into sine and cosine, you won't go wrong. Well, Hubert, why didn't you do anything to this? Well, the directions say prove that this is equal to this, or prove that this is equal to this. You always go with the most complicated. And I went with the most complicated. All right, let's do another one. Yep, that's what they got. Verify that the following equation is an identity. Write that one down. Oh, man. I don't know why I'm yawning so much. Why do you yawn? I'm not sleepy. Tangent minus cotangent of t over sine t cosine t equals secant squared t minus cosecant squared t. Well, I don't want to mess with that secant squared and cosecant squared. We could, I mean, you could if you wanted to, but I'm going to mess with that tangent and cotangent. Maybe that would be easier to deal with because tan is sine over cosine and cotangent is cosine over sine. Yeah, I think I'd rather fool with the left-hand side. I don't know. We may run into a dead end. Sine t cosine t minus cosine t sine t. You got to get a common denominator there. Over sine t cosine t over 1. And get a common denominator of cosine and sine. So that's going to be equal to sine cosine cosine will go into cosine, sine, cosine, sine times, that'll be sine squared. Cosine will go into cosine, or sine times. Wait a minute. Did I just mess up? Hold on. Yeah, that's right. Cosine will go into sine squared, or sine will go into cosine. This will be cosine squared. I just had a brain bubble. I'm sorry. And all that's over sine, cosine. And what do you do when you multiply by or divide by a fraction?
You flip
What do
it
you
and
do when
multiply.
you divide by a fraction? You multiply
and
by the
multiply.
reciprocal. Yeah, that's right. I don't know if I'm heading to the dead end on this or not. So that's going to be sine squared. That's 1. 1 over sine x cosine x multiplied by 1 over sine squared x cosine x. Sorry. Cosine x, sine x, cosine x. Well, I get 1 over sine squared x cosine squared x. That don't look like what we need. Wait a minute. 1 over sine squared.
Is that not just 1?
1 over cosine squared is secant. Yeah,
Multiplied.
but it should be minus. I should have a minus sign there. Hold on. Yeah, it should be a minus. Hold on. Let me make sure. Wait a minute. I should have sine squared. I should have. Okay, I think I just had a brain bubble here. Let me start off. Let me start off from here again. I think the Benadryl is getting to me again. Okay, sine squared t minus cosine squared t over sine cosine multiplied by 1 over sine cosine. That looks better. And that would be sine squared t minus cosine squared t over sine squared times cosine squared. Does that look better? And this is going to be sine squared t over sine squared t cosine squared t minus cosine squared t over sine squared t cosine squared t. And that's going to cancel that out and leave 1 over cosine squared t minus, that cancels that out, 1 over sine squared t. And what's 1 over cosine squared? 1 over the cosine is equal to the what? Secant squared? Yes, you.
Yes.
And 1 over the cosine, or 1 over the sine, is the cosecant squared. And what did they want? What was their valid? Should be secant squared minus cosecant squared. Let's see what they wanted. Secant squared minus cosecant squared. We are smart.
We feel good about ourselves.
Do you? Good job. I'm not believing somebody said that.
Do you mind putting that up back up for just a second?
I'm sorry, what'd you say?
You mind putting like the last part of that back up for just a second?
You talking about this part, or that's the
Yeah.
first part,
Uh,
or that part?
That part, just for a second, because I had a hard time seeing it.
Okay. Well, I kind of got small toward the end. I'm sorry.
No, you're fine.
How many of you like puzzles and Rubik's cubes and the two horseshoes on the chain? That's what this is. A lot of people say, well, Hubert, will anybody ever walk up to me and ask me what this? No. But what is solving a problem? Taking stuff apart and putting it what? Back together. And that's what you're doing here.
Okay,
You're
I got
taking it apart and putting it together. It's nothing but calisthenics for the problem-solving process of your brain. The redneck way is to say, I ain't gonna ever use this stuff. Well, that's redneck. Shut up. You got that, Miss Croxton?
Yes, sir.
I'm sorry that Benadryl kicked in the middle of that thing. I don't know why. I gotta quit taking that stuff. All right. Verify that the following equation is an identity. Wait a minute, is this the same problem? They don't. Oh, this is the same. Yeah, it's the same problem. Okay, I'm gonna let y'all do this one. Verify that cosine of x over 1 minus the sine of x is equal to 1 plus sine of x over cosine of x. Give y'all a couple of minutes. Now you got to pull up something from algebra here. You're not going to like it.
I mean, I'm going to give you total transparency. I don't really like any of this so far.
I know, but you got to go through it. You got to energize your brain with taking things apart and put them back together again.
Yeah.
So you can be an engineer. And so your bridge don't fall and kill 10,000 people. Or your part that you design as a mechanical engineer does not falter and blow up Apollo 13. So I'm going to take this side right here. Now you can take either side. I'm going to take that side because I'm right-handed. So I'm going to take that side. So I'm going to make it look like this. So I'm going to go down here and I'm going to say 1 plus sine of x over cosine of x. Well, Hubert, they already in cosine and sine. What are you going to do? Well, you see this right here, 1 plus sine of x. I'm going to multiply by the conjugate. I'm going to multiply by 1 minus cosine of x, or 1 minus sine of x. And somebody tell me what that will give me on the top up here. Shortcut number what? Number 3, Hubert. That's what I was going to tell you. Y'all ain't going to like this because y'all try to push those shortcuts under the rug and not learn them. And they plague you all the way up to differential equations. So this is a plus b, a minus b is equal to a squared minus b squared. So that will be parentheses squared minus parentheses squared, which is going to be 1 and sine of x over cosine of x times 1 minus sine of x. All right, now I want you to finish it because I think you can finish it if you do your algebra and maybe look at the Pythagorean theorem, Pythagorean identity. I think you could finish it. And if you can't, we're going to make fun of you. Mr. Nicholson, we're going to make fun of you.
I've already accepted that fact. I'm just here doing what I can, getting made fun of. So
At least you have a sense of humor, Mr. Nicholson. You're not going to be in a closet office. You're going to have a nice office one day. You're not going to be in a closet where nobody wants to talk to you. You know, I tell you, some of these people and what they put on Facebook, I just don't understand people. I'm just going to leave it at that. Somebody tell me what we get on the numerator. Come on, what do we get? What's 1 squared?
1 squared. That would
be 1.
that would just be 1.
And what is sine x squared?
It would just be sine 2x.
Sine squared of x. And I'm going to distribute this guy. No, I'm not going to distribute that. Leave that alone. Because we might be able to cancel that cosine out. Because what is 1 minus sine squared of x?
Cosine squared.
1 minus cosine squared of x is equal to what? Or 1 minus sine squared. It's equal to cosine squared right there. So we're going to get cosine squared of x divided by cosine of x times 1 minus sine of x. I didn't distribute that cosine. I thought we might want to leave it. Cosine of x, 1 minus sine of x. And I brought it down here. Now somebody tell me what can happen with these two.
You can
Now
cancel
get
them out.
that red pen out. What does that red pen do?
Cancels them out.
All right, so cosine squared over cosine is cosine of x over this. Because the cosine, this cosine goes away, and one of these cosines goes away and leaves, or I could write it like this. Cosine of x times cosine of x over cosine of x times 1 minus sine of x. And what happens to these two cosines? You cancel, Hubert. That's right, class. So either way, you're going to get cosine of x over 1 minus sine of x. Now finish it. And all you got to do is basic fraction work now. All you got to do is maybe 1 or 2 more steps. Can somebody tell me what to do? Cosine over 1 minus cosine over what? You could go further, but I think that's all we needed was this right here, wasn't it?
Yeah, that's all we need. That
Yeah, because this would be cosine. Yeah, you don't need this. You don't need that. All right, try that one. Secant secant of alpha plus tangent of alpha over secant alpha minus tangent alpha is equal to 1 plus 2 sine of alpha plus sine squared alpha over cosine squared of alpha. I think I'm gonna deal with the left-hand side. Take a minute or two. All right. I'm going to take the left-hand side right here, and I'm going to multiply it by cosine over cosine. Now, a lot of people say, well, why are you going to do that? Well, remember, I want to try to get these things in terms of cosine and sine. So if I multiply by cosine over cosine, that'll get it started. Because tangent is equal to sine over cosine, and secant is equal to 1 over sine, or 1 over cosine. That's another thing you could do. You could do it that way, change everything into sine and cosine, and multiply through. But I'm going to start off, and let's see, sine, cosine, tangent, cotangent, secant. So that'd be 1 over the cosine plus sine over cosine. Yeah, you could go that route if you wanted to. But I'm going to go through and multiply by the cosine on top and bottom. So secant theta plus tangent theta, or not theta, it's alpha, but whatever, it's the same thing. It's a variable, over secant minus tangent. And I'm going to multiply both the top and the bottom by cosine. Now, quite possibly, I could do it with sine, but I want to use cosine because I want to try to get everything, because that's a cosine right here. And that's why I'm starting with cosine to see if that'll help. So we got cosine secant x, or secant x cosine of x, plus tangent x cosine x over secant x cosine x plus minus tangent x cosine of x. Now here we got the same sign, and we got secant cosine, secant cosine. This is 1 over 1. So I'm going to rewrite this and say 1 plus tan cosine over 1 minus tan cosine. Now rewrite tan in terms of, I want y'all to do this, rewrite tan in terms of sine and cosine and keep going. Rewrite the tan as sine over cosine and keep going. So 1 plus sine x over cosine x times cosine of x over 1. 1 minus sine x over cosine x times cosine x over 1. And look what happens. What happens to the cosines? You're left with 1 plus sine of x over 1 minus the sine of x. Now let's keep that in our brain housing group. And now let's do the right-hand side. Let's do the right-hand side.
To cancel.
You got to go back to the original 1 plus 2. Right here, you got to go back to this. And it's algebra. It's nothing but algebra. So go back to the right-hand side and see if you can do something with it. I'll tell you one thing, that numerator can be simplified. Somebody tell me what it looks like. 1 plus 2 sine x plus sine squared x. What does it look like? There's Miss Hernandez. She looks like today she is the rainbow Unabomber. All she needs is some black glasses. She could be the rainbow Unabomber. Because everybody today is wearing hoodies. I had like 5 people in one class have hoodies on today. I'm like, you're not outside. Why are you wearing hoodies? They try to be the Unabomber. What's sad is half of y'all don't even know what I'm talking about. That's what's sad.
It's cold.
It's cold. It ain't cold.
Nah, I'm that one person that'll wear a jacket if it's 90 degrees.
Oh yeah, outside. You the 96-year-old lady. Always cold in here. It's cold in here.
I always been like that as a kid. It'd be 100 degrees outside. I still have a hoodie on.
All right, so I'm gonna go back up here. And I want to just draw a line down through here like this. Somebody tell me what this is. That's a quadratic. That's 1 plus sine, shortcut number 2 that y'all refuse to learn. Shortcut number 1, sorry. Which is 1 plus sine x, quantity what? Squared, over What is the cosine squared? It could be written as what? 1 minus sine squared. 1 minus sine squared x. And this equals 1 plus sine squared over 1 plus sine times 1 minus the sine. And that's shortcut number 3. So shortcut number 3 is from there to there. A minus B, A squared minus B squared is equal to A plus B times A minus B. And look what happens to one of these. What happens to one of those 1 plus sine x? What happens to one of them? Cancel. And you're left with, look here, 1 plus sine of x over 1 minus what? And I just wonder if that looks like it's a miracle. So that's one of those that's one of those identities that you have to prove both sides. Okay, that's gonna fry y'all's brain today. So I think we better take what we can, because I don't know if y'all gonna take much more. Hold on a second. We can do one more. I think we got time for one more, but I don't know. Let me see if I can find one. No, I don't have one in the, no, there's none in the slides. We've done all the ones in the slides. So let's just go ahead and call it a day. Now, should you be able to work, well, we can go to 10.2. Let me look at 10.2, see if we can find one in there. 10.2, where's my 10.2? Hold on, I'm pulling it up. Ten point two. And 10.2 let's see what it starts off with. Sum and difference. No, I don't want to go there yet. We're going to go ahead and stop at 10.1. I want y'all to work on 10.1 over the weekend and send questions, because 10.1, you're going to have questions. So let's go ahead and stop for today. And I will, let's see, Shirley, okay, they're back. Okay, see anybody else left. Okay, so let me stop the recording.